So example 13 shows us how to evaluate a word problem using these same concepts. So Devin is a real person. He's a friend of mine. He's actually a Gator fan, and this problem was written for him, and it's totally something he would do in real life. But it says, Devin was so upset about Florida's crushing loss to Georgia this season that he climbed a tree after the game and wouldn't come down. His friends Eric and Scotty need a ladder to retrieve him, but don't know how tall the tree is. If Eric is standing to the left of the tree with an angle of elevation of 21 degrees, and his distance to the top of the tree is 42 meters, Scotty is standing to the right of the tree with an angle of elevation of 47 degrees. Answer the following. So before I start answering any of these parts, I just want to get down on this diagram. That was a lot of information that was thrown at me. So the first thing it said was Eric is to the left of the tree, and the angle of elevation was 21 degrees. So the angle of elevation means if he's standing on the ground looking straight ahead, he has to look up at an angle of 21 degrees to see the top of the tree. The distance from him to the top of the tree was 42 meters, and that was labeled on the diagram. Scotty's standing to the right of the tree, and her angle of elevation is 47 degrees. So here's Scotty, and here's Eric. So question 1 says, well, how tall does the ladder, or long does the ladder need to be to reach Devin if their plan is to climb straight up the tree? So another way of thinking about this question is they're really asking how tall is the tree, right? Because they're just going to put the ladder vertically right up against it, and we want to know what is the height h of that tree. So as we can see, I now have 2 triangles, right triangles that I can deal with. So if we look at the triangle on the left, I actually know more information here. I know the angle, I know one of the sides, and I'm looking for the other side. So the side I want is the side opposite, and the side I have is the adjacent side. So opposite over adjacent is sine. So I can say, well, the sine of 21 degrees is h over 42. So 42 times the sine of 21 degrees equals h. So that's the length of the ladder. Question 2, or part B, says, well, how far apart are they from each other? So what I want to know is, what is this total distance? So it's still easier for me to work with right triangles. So I'm going to call Eric's distance from the tree x and Scotty's distance from the tree y. So that means the total distance they are from each other is x plus y. So if I can find x and y, then I can add them together to get this distance. So in the first triangle on the left, well, it's easier for me to work with 42 than it is for me to work with this expression for h. So I'm going to say, well, I know the angle, I know I'm looking for the adjacent side, and I know the hypotenuse. So I'm going to use cosine. So cosine of 21 degrees is the adjacent side over the hypotenuse. So 42 cosine 21 degrees is x. If we go to the right triangle, well, I'm looking for y, the adjacent side, right? But the only thing I know is the opposite side, h. So I'm going to have to use tangent. So tangent of 47 degrees is opposite over adjacent. So I'm going to solve this for y and get that y is h divided by tangent of 47. And you really want to take advantage of your reciprocal identities when you're doing these problems, because writing this big fraction is cumbersome, but I know 1 over tangent is cotangent. So I can say, well, this is h times cotangent of 47. And now let's plug in what h is. So h was 42 sine 21 degrees, right, times cotangent of 47 degrees. So the distance is x plus y. that is your final exact answer. You were not asked to approximate anything, so you wouldn't have to type anything into your calculator.